Okay, today we're going to look at several types of crater formation. Actually, two basic types: the impact, which is well known, impact crater, and then the electric formation. And which in the electric we'll do three different tests with three different electrodes using arc mode lightning and also dark mode discharges with the broader based electrodes and parabolic or curved shaped electrodes. And so the first one we want to do here, we'll go ahead and try, is the arc mode discharge, and we're using a 90 kV transformer, rectifier, 4-way bridge rectifier, and 6,000 picofarad capacitor. And I'll turn on the variac here, and we'll turn this up and allow the arc to start going. Zoom in there, let's watch that. Had a strong enough arc, we could do this all at once, but really no different by doing it. Notice the deeper it gets, the faster it goes, because the distance to the conductor is less resistance. Pretty good for demonstration. You'll notice that this type of arc will literally eat through the dielectric all the way to the conductor if allowed to, creating a very deep cone shaped crater. Then we discharge this right quick, and then we'll change these electrodes out. In there, let you see that. And you'll notice a slight bit of a rim around it, but not really a defined raising around the rim. You'll take note. Let's go ahead and change out, put another electrode. This time we're going to use a curved electrode, a parabolic shape, which is just simply the spoon. We'll set here, and if it's down low enough, it'll actually pull the center up while etching around the outside. Let's see if we can get that to happen without an arc. Move it over just a little bit more. Get the camera over there. In, focused. Okay. Go ahead and let it keep going. Keep those arcs out. You immediately notice the rim being built around the outside edge. Much similar to what we see. Put that over and discharge it. You'll notice the edge of this crater is really defined and sharp and smooth, especially on the inside there of the crater wall. It's really smooth. The next test will be a broad base but flat electrode, which would just be a disc, a flat disc. These just spread the current out over wider areas, in my opinion. Do it right here. down. A little bit more. Careful on it. Okay. Notice we tend to see the rays around this more than the other two. You'll notice these straight lines of debris emanating from the center, which we do not see as much of with the other two. All right, there. Turn that off. Move it over and discharge it. And you'll see this has a bit more of what we do see actually in the flatter bottom, the etched edges with the raised rim, slightly raised rim, and again with the rays around it. And the final crater we'll do with the I have a high-end pellet rifle here that shoots 1,000 feet per second. I know that's not comparable with an actual asteroid or meteor, but at this scale you'll see it's quite appropriate. So we're going to shoot this at about 60 degrees, 65 degrees. You'll see it. Notice that crater is, well, you have a lack of rays. The fingers pointing from the center out. You also have a lack of an actual defined rim. There's no rim there with that type of impact. I just wanted to show all these in the same medium of the significant. At any rate, take a look at them. You'll see that not only lightning and an impact can create a crater. In fact, the flat bottom craters may very well have been product of a dark mode energy discharge. At any rate, peace out.